Hey, I'm Ethan, and welcome back to Fun with Electronics. Today we're going to be covering the various components that make up an Arduino and how to interact with them. A quick reminder that if you enjoy our content and want to see more about topics ranging from circuit concepts to Arduinos, please subscribe to our YouTube channel. It's completely free, and you can unsubscribe at any time. Last lesson, we went over what an Arduino actually was, and how to download the Arduino IDE, so if you would like to catch up, feel free to click on the button in the top right. With the intro out of the way, let's jump straight into the video. For the purposes of this video, we will be using the Arduino Uno R3 because it's the most widespread version. To make sure that you have the correct type of Arduino, make sure to locate the Arduino Uno logo. When explaining the different components of an Arduino, I like to split them up into two categories: the components that you can touch and interact with, and the components that you should leave be. First, I will go over the components that you should typically avoid touching, one of which is the main IC, which is considered the brains of the Arduino. Be sure not to touch it, as breaking it would make the Arduino inoperable. Next, we have the voltage regulator, which, you guessed it, regulates the voltage coming into an Arduino. This is so none of the components get damaged. However, if you put a voltage of over 20 volts through the voltage regulator, it will break, thus destroying the entire Arduino. Now, let's go over the parts of an Arduino that you can interact with visually or through touch. The two components are the main charging ports of an Arduino: the 2.1mm DC power port and the USB Type-B port. Although both can be used, the USB-B port is more popular. This is because it allows a USB-B to A cord to easily connect the Arduino to the computer, thus allowing you to download code from the Arduino IDE. In addition to providing a direct connection to the computer, the USB-B to A cord is also significantly cheaper. Although I have both of these wires linked in the description down below, I recommend only buying the USB-B to A cord, because we will be using it for all the future demonstrations. Now that we know how to charge an Arduino, let's turn it on. Once it is booted up, notice that the on button starts to shine. If it doesn't, then it's likely that something is wrong with your Arduino. There are also several other lights in the Arduino that light up in response to other Arduino related actions. For instance, the RX light, which is short for receive, turns on when an Arduino downloads a new program from a computer. Meanwhile, the TX light, which is short for transmit, shines when an Arduino transmits information to another device. Now, let's move on to the components that you actually touch, such as the reset button. This comes in handy when you would like to reset a current program that you are running. So let's say I'm running a program on my OLED board that runs a series of animations. If I want to go to the first animation, I can simply press the button and it restarts. And with all the buttons, charging ports, and LEDs out of the way, let's move on to what makes the Arduino so unique and powerful: its pins. An easy way to define a pin is something on an Arduino that you could plug a wire into. By plugging in a wire, many different types of tasks can be accomplished, ranging from distributing electricity to taking in data from sensors. Although there are quite a few different types of pins, I will go over the main types you will need to use. First, we will go over the 5V and 3.3V pins. These pins do nothing more than supply a steady voltage through whatever wire is plugged into them. However, to actually use the voltage to power any projects, the circuit has to end at a ground pin, which you can think of as a negative terminal. With those two parts of a circuit complete, you can finally embark on projects like a shining LED. Next, we have the digital pins, which are labeled 0, 1, 2, 4, 7, 8, 12, and 13, and they all lack a tilde. You can think of them as 5V pins that can be turned on and off through code. However, they can't emit any voltage value between 0 and 5. With this functionality, you can create projects like a blinking LED. In addition to outputting voltage, these pins can also take in voltage values from buttons and sensors, which enables the Arduino to see if a button is pressed or not. As you can see, after pressing the button, my console displays 1s, which means on, and when the button is not pressed, the console displays 0s, which means off. In order to supply a voltage between 0 and 5, unlike digital pins, you would have to utilize a new type of pin called a PWM, which has the labels of 3, 5, 6, 9, 10, and 11 with a tilde. PWM pins are able to go between 0 and 5 due to an interesting process. By switching between 0 and 5 volts for different time intervals, a voltage between the two values can be simulated. You can see it in this GIF. The more time you spend at 0 volts, the lower the resulting voltage, and the more time you spend at 5 volts, the higher the resulting voltage. With adequate code written in the Arduino IDE, PWM pins allow us to make projects like a dimming light bulb. Just like the digital pins, PWM pins can take in values from sensors and buttons of 0 and 5 without the functionality to read anything in between. In order to take intake values from sensors between 0 and 5, we have a new pin called an analog pin, which is labeled A0 through A5. Think of these pins as the reverse of the PWM pins, as instead of outputting a wide array of voltage, it can now input and process a wide array of voltage. I personally use analog pins for my more complicated projects involving OLED displays, ultrasonic sensors, thermistors, and Bluetooth modules. One easy example for when to use an analog pin is if I want to see how many volts a battery emits. After connecting the wires and writing the code, I can look into my COM window and see the voltage. As you can see here, the positive terminal of the battery is connected to the A0 pin, and the negative terminal of the battery is connected to the ground pin. This enables the Arduino to detect the voltage of the battery, which is 3 in this case. After the voltage is detected, my code translates the raw data into a number in the COM window. Batteries aren't the only things you can detect voltage from. For instance, if my hands hold the 2 wires, my body's non-existent voltage can be detected, and it will show up as a 0 in the COM window. There is also another important pin I didn't mention because it didn't fit in with any of the categories. It's called the VIN pin, which has the capability to take electricity from any source like a battery. This can be viewed as a substitute for using a computer or an outlet as a power source for the Arduino, though it is not recommended as most batteries are not rechargeable. However, if you still want to power the Arduino with a battery, just connect the positive terminal to the VIN and the negative to the ground. You can find the compatible batteries in the description down below. And with that, you are done. If you have any questions about anything I went over today, feel free to ask in the comments section. Our next lesson in this Arduino tutorial playlist will be going over the basics of coding using an Arduino IDE, so feel free to tune in. If you like this video and would like to watch some more content, I would appreciate it if you would like this video and subscribe to the Fun with Electronics YouTube channel. You can also click on the notification bell to get updates on whenever we post a new video. Until then, stay creative and have a great day.